everyone. I'm Rob May. I'm the CEO of Neurometric.
And I'm Calvin Cooper, COO here at Neurometric. We're co-founders. This is Inference Time Tactics, a podcast for builders, researchers, and engineers who want to know what's happening with this next era of AI.
Today we have one of our other co-founders, our CTO, Byron Galbraith, is with us because we have a little bit of a technical discussion today, more so than usual. Our guest is Prashanth Velidandi, and he is a co-founder of InferX, which is a multi-tenant serverless platform for scalable inference that can deliver sub 2-second cold starts and high GPU efficiency, which is pretty impressive if you guys can really do that.
Absolutely. And again, thanks for inviting me here. And it's a great opportunity for me to vent out what I've been holding for a long time, because this needs to be spoken out, literally. What is InferX? InferX is basically, what we are solving is AI iceberg problem, basically. If you look at it, most of the focus has been on the models training side until then. But that's only the tip of the iceberg, right? It's only like a 10% of it. So if you look at the model lifecycle, actually, the 90% of the model lifecycle lives in the inference, actually. That's the 90% of the part. It's never been talked about until now. It's always about how big, beautiful the models are. So that is exactly where we are delivering here, the 80% GPU utilization and with a 2-second cold start. So there's a dirty secret in the industry that 80% of the GPU is actually sitting idle. The AI inference. So with our operating system for AI compute, that is exactly what we are solving here. So we are a serverless AI inference platform. So our goal is to provide efficient inference at scale at the production environment.
And just for people that may not be familiar with some of these terms, if you're listening and you're not super technical. So serverless basically means like it does live on a server somewhere or whatever. It's just the customer accesses it just via an API call, right?
That's very true, yes. Yeah. Basically, the multiple characteristics for the serverless here, right? So yes, you had to abstract away the infrastructure, first of all. So the user is not actually managing the infrastructure at all. And also you have to deliver the product on demand, literally. So the user is only paying for that execution time, that moment of the execution, basically. So you're not just paying for the idle time, model loading time or something like that. So you're only paying for that couple of seconds that you're inferencing. Yes.
Yeah. And then part of the reason this problem exists, one reason I know that GPUs sit idle is you have these giant models and the GPU can only process so many neurons at a single time. So you load those neurons in from memory and you process those. And then you store those results to memory and you process some more. And so a lot of times it's sitting idle because you're shuffling data back and forth. Are there other reasons that GPUs are idle?
Yeah, basically that is the only reason the GPU is sitting idle is because the cold start problem. That's been a huge bottleneck in the industry. The cold start problem is basically the amount of time the model it takes to load into the GPU VRAM, right? So what happens is, because of that, then it kills the user experience. That's what happens. So in the traditional system, what they do is they keep the model live and the GPU 24/7, literally, just to avoid that cold start latency, right, basically. And with that, inference is very bursty. In 1 hour, there may be 1,000 requests. In the next hour, there could be 0. But this GPU is actually provisioned for the peak time. And during the non-peak time, this GPU just sitting idle. And that's about 80% of the time, literally, because inference is so sporadic and the bursty traffic.
What did we see, Byron? I think we have a conversation about this, loading some of our stuff, like 7 minutes to load a model in or something like that?
It really depends, yeah. So again, as I think was mentioned, there are many, if you're trying to load your own models, especially on your own infrastructure, it can take several seconds to get all those gigabytes of all the model things over onto the VRAM. And so there is a delay that you have to deal with.
How did you come to this insight? I thought something interesting in your background was your founder's journey. You were studying international business? Right?
Yes. My background is mostly business, actually. So I'm also working on my doctorate right now. And so a couple of years ago, I met my co-founder through Y Combinator. And he contacted me and he told me about this InferX that he's been building over 6 years of time, actually. Wow. So my co-founder, Brad, he was the ex-chief architect for Huawei Cloud. So he built their serverless systems there and is a mad scientist. And he reached out to me and he needed a business person to take it to the market, basically. And I didn't know anything about the GPU, the infrastructure. All I knew was ChatGPT. That's all about it. Then my fascination started. He reached out to me. I took a month or so and I looked into this. And then when I did my own research, and it looked like, oh, wow, this is going to be a really essential foundational layer to run the models actually under the hood. And then I had to self-teach myself about the infrastructure. Okay, what it really takes to run the model to execute the model efficiently. And back in January, we saw the seismic explosion of DeepSeek, basically. That literally changed everything, right? Until then, closed source model, OpenAI, Anthropic, they were ruling. DeepSeek literally changed everything. So then they released this open source model that's as good as the ChatGPT. And then the problem then is, okay, how do you run this model, right? Literally. And then, yes, open source doesn't mean that it's just open source, it's free. So just like Dario of Anthropic says, you really have to execute this model some place, and you have to execute it efficiently. So that's how it started. And then I got into the AI infrastructure research, how efficient the traditional system is, the cloud infrastructure is, and we are really trying to push everything, AI into the traditional system. But it's not sustainable. And that's how it started.
And now you're doing your dissertation on this topic?
Exactly. That's the beautiful part, actually. So then I literally pivoted to the AI infrastructure because this is such a fascinating subject. It's not an American issue or a Chinese issue. It's like a global phenomenon, right? So because the AI, so just like Sam Altman says, the future of economy is going to be the AI compute. That is exactly what we're talking about here. Yes, everything is going to be around the AI and AI compute and how you manage it efficiently, basically. So that is the reason. It's a very fascinating. I'm obsessed with this, and it's been really an enjoyable experience for me, literally. Yeah. So there is AI, and then we have a cloud infrastructure out there. So basic cloud infrastructure, actually, traditionally, it's not built for the AI at all. Literally, it's built for the microservices, like web applications, and you are trying to push the AI. AI is these large language models are a very stateful applications, basically. Okay, there's a context around, there's a memory associated with that. Okay, it's not like you're just opening an app, like an airline app, and just booking your ticket and be gone, right? So you're building context on top of that. So that's what makes it different. That's what makes the AI models different, basically. So essentially, the cloud infrastructure is not at all built for the AI. So you're trying to execute something like AI, as complex as AI, on a cloud that is built for the e-commerce, basically e-commerce website, literally. So it's not sustainable at all. And it's going to break at some point. And that is exactly the reason I got into this. And then that is exactly the entire focus of InferX is around it. So basically, we need to build something from the ground up. Just like Mark Anderson of A16Z says, everything is going to be rebuilt. That is exactly what we are talking about, because AI needs its own strategy for the infrastructure. So that's the underlying journey of the AI research. Yeah.
One of the things that's really interesting about serverless, right, and how this works. So you're talking about building this technology for cloud providers, as I understand it. So can you get into how what's the core thing that solves the cold start problem? Is it sort of snapshotting VRAM and doing smart data movement? Can you go into a little bit about how it works?
The problem we are solving, the cost of the inference. That is the goal of it. So we need to reduce the cost of the inference, because in the future there's going to be millions of models, billions of models, if not, right? So Greg Brockman says everybody is going to have their own GPU, literally. That means they're going to have their models as well. But we don't really need an infrastructure to run all these models at somewhere. So basically what we do is in the serverless we do it as serverless manner. It's like AWS, it's like a Lambda for inference, let's say. So what happens is when you manually load the model into the GPU, we take this GPU state and the CPU state of the model, and then we store them in the system memory instead of keeping it alive on the GPU VRAM. And then we only bring it into the GPU VRAM on demand and undertake only when there's a request, and then the model gets evicted and the GPU becomes available for the next workload. So that's how you can deploy 40, 50 models depending on your system memory size, and you can just serve them on demand. So that's how it gets served on the peak time, and during the non-peak time as well. Actually, you can also use it for the fine-tuning as well at the same time. So our goal is to keep the GPU compute utilized 100% of the time without keeping it alive. So that's a snapshot technology. That's our patent pending technology. It's extremely complex process, because you have to freeze the state of the LLM at that point, and then you have to capture that, and then you have to load it. you had to unload it, and then you had to load it back into the VRAM at that exact state. So that is a highly complex process, but it took us almost 5 to 6 years to figure out. And then now we are here, and we are the only one leading in the industry right now.
And so, given that it's a complex process and it's a very deeply technical thing, like before the podcast started, you and I were talking about the fact that it's not a difficult thing to sell when people get it, but it's a difficult thing for people to understand the extent to which they have the problem and what the possible solution sets are. Because one of the problems with the AI stack is it's so complicated and there's a whole bunch of new parts. There's very few people that understand how they all work together. So how have you guys approached that as a young company to like, do you have to do a lot of market education? Has it been hard to find a singular customer persona? Like what's the GDM experience been like?
That's actually been a very tough, that's been a tough experience for us, to be honest, even to tell people that, okay, we can do the serverless for the AI inference, literally. Like, how can you do serverless? Because the model is so big. How can you load the model into the GPU VRAM so quickly and unload it, and then make it available for the next workload? No, it's impossible because it's LLMs are tens of gigabytes. That's impossible, literally. And that is exactly what our snapshot technology brings it, right? So it's unspoken. It's a very brand new. It's never been thought of, literally. It's like, oh, why didn't we make it possible? I mean, everybody is trying to just see quantize the model and then make it condense the model, and so they can decrease the loading time. That's all they were focusing on. But what we brought in with our snapshot technology is the whole new paradigm, actually, in serving the AI inference. So it's been very hard for us actually to convince people about it. This is really possible. But there are few folks actually that do understand. Actually, Google Cloud actually recently came up with their own Google Cloud serverless platform. Actually, they are trying to do the similar cold start. They're also tackling the cold start problem. They actually reached out to us to collaborate, and to think about it, we'll see. Yeah. What they did, they actually published this blog back in June, so they can load a simple like a Gemma 4B model in 19 seconds. It took them 19 seconds. Wow. Imagine you're calling a API for a Gemma 4B model and you're just sitting there for 19 seconds.
Yeah,
that kills the user experience, right? So with us, we can do the same model in under half a second.
Wow.
That's how advanced we are. It's like almost a 40 times efficiency. So yes, explaining it to people, but I mean, we are slowly getting there. Actually, now people understand. I mean, what user wants is they want to abstract away all this infrastructure. They don't want to understand all this. You run the model for me, and that's it. And I want to pay only for that moment of the execution. That's it. They don't want to understand, okay, how are you doing it in the background, right? And how are you abstracting away your complexity and all the stuff? So that's for us to decide. So that's actually, when we go to the people, we will rather go in a simple, hey, you are only paying as you go, basically, on demand, just like you did for the Lambda for AWS Lambda for CPU workloads. Yeah, that's exactly what we are doing for the GPUs.
Yeah, well, it does seem like as you start to get more proof points and more people in market doing it, it should really take off, because it's very exciting technology.
Oh yeah, absolutely. Actually, it's been tremendous. I mean, we're for long away ever since we started back in May. People are more understanding now, and also many people are trying to replicate as a matter of fact, actually. But it's a very complicated technology, and we know that it's not so simple. But sure, why not?
Related to that, just want to kind of think about like heterogeneous systems, aging systems. Does the technology require specific hardware? Like, does it only work on NVIDIA H100s, or can it work on any GPU, different platforms, different hardware device settings?
That's another beautiful question, actually, because that gets really complicated. We have GPUs, okay? Even within NVIDIA, every GPU is different. We think, okay, just a CUDA and it's just simple. Okay, you can just load it and unload it, and you can unload it on a different GPU, and you can load it on a different GPU, right? No, H100 is so different from the B200 or B100 and from the A100, actually. So it's a very complex system out there. But our technology is built for any GPU out there, literally. It doesn't matter if it is built on top of CUDA or ROCm of AMD, even Huawei, actually. This can be done on top of the Huawei as well. So our goal is to make it hardware agnostic, model agnostic, the framework agnostic at the same time. So that way, developers can decide where to run, how to run efficiently. So that is our goal. So make it easy for them. So basically, even for the cloud providers or even enterprises, I mean, it's going to be vendor agnostic. So they can run this software on top of any GPU they got, literally. So that is how easy we are making it to run the AI models in the production scale. Yes.
Yeah, I mean, where my head goes is like you're solving really important problems in the inference stack. What are people doing with this technology? Enterprises are investing a lot in infrastructure. 90% of them believe that agentic AI will provide competitive advantage. But what are those advantages? What kind of use cases are being enabled?
I mean, its future is going to be, agents, like a multi-agent environment. That's exactly what we're. But we need an infrastructure to run these agents somewhere. That is exactly the underlying problem no one talks about. And also to run these efficiently, not just to run them and execute them, right? And enterprises, for the first thing for them is the problem for them is the cost. Okay, how can we serve all these models efficiently in the production scale? And as far as our technology is concerned, what enterprise can do with our software is basically they can run more models literally with way less GPUs. For example, if they're running 50 models and using 50 GPUs for those models, by adding InferX on top of it, they can run those 50 models just with 3 GPUs, basically. That is exactly the kind of efficiency we're bringing here. So that means it directly, dramatically decreases the cost of infrastructure, and then they can provide it to the end user eventually. So that is our goal here. So that is, it can be deployed both on the cloud as well, cloud providers as well as the enterprise as well. And in the future, we're going to be seeing more hybrid versions of, this is not going to be the same, or enterprise are going to run their workloads only on certain cloud. I think it's going to be more agnostic, have multi-cloud systems or on-prem systems. So that's exactly what we'll, so InferX can be deployed both on the cloud and also on-prem as well. So just take one example. If you have one H100, and then you can run InferX on top of that as an operating system, and then you can serve 40, 50 models just like that on a single H100. That is exactly what the efficiency we are talking about, instead of just adding on GPUs on top of each other.
That's cool. And so do you see people primarily like choosing you guys when they're starting up, or and they just want something simple to use? Or is it more like they've struggled with, managing some of their infrastructure and they're trying to simplify stuff there? Is there a common path that drives people to make a serverless GPU choice?
Yeah. So, the first in the stack is basically any developers or any teams. They want to go towards a serverless API, so they don't have to manage the infrastructure, and then they can just call the API, and then simple. And then what happens is, and when they looked at the bills, because of the inefficiency, and that's it. And then they decide, this is not the way to go. And then they move down the stack, and then, okay, how about we manage our own infrastructure, and we build our own stack, and then bring in a couple of CUDA engineers, and we build our own software. It's not so easy because engineers are expensive. That's our first thing. CUDA, there is a huge scarcity of CUDA developers actually, and it adds even more efficiency, and it's not sustainable either. So basically, and that's exactly when InferX comes in to fill this gap. So they can literally deploy InferX on top of their entire infrastructure, and they run their models very efficiently on demand, just like that. We literally abstract away any complexity behind running the models. So all you need is, if you're really self-hosting, if you have proper hardware, S100, N100, even AMDs, or even Huawei, they're coming pretty hard against NVIDIA, obviously. But so yeah, any hardware literally, and then we will run on top of you, and that's it. You don't really need to manage anything. So, and we will make it easier for you. And then so you can focus on your actual product than managing the infrastructure. So yeah, that's the goal of InferX basically.
Where do you think we are in the market cycle in terms of companies actually thinking about inference and the importance of inference? Because again, like we were talking before the podcast started, everybody's been so obsessed with training and what are the capabilities of the latest models and pilots and everything else. Like, what are you seeing in the market? Are there 2% of companies really doing AI and mature enough that they care about inference? Is it 10%? Is it 40%? Like where are we in that early market adoption phase for the number of companies that are mature enough to be able to say like, we're thinking a lot about inference. Like obviously it's going to be everybody in a couple of years, but like
not a couple even years.
Where are we now?
I wouldn't even say a couple of years actually. I mean, you will see the system breaking literally probably in like 6 months. That's what we're talking about, because if people are noticing now, yes, they're hiding it behind now, but this will be noticed. This will be it's a very dirty secret we're trying to hide, but at some point it's going to come out. So yes, until now, the focus has been on the training, and this has been very true for us as well. Just a couple of weeks ago, I don't know if you saw Larry Ellison on their earnings call.
Yeah.
He is talking about inference is going to be 10 times
is going to come from. Yeah.
10 times bigger than training, because the training is like, if you're building a factory, right? That's like building an LLM. You built a LLM as a factory, let's say. That's a factory. But the inference is actually this like a day-to-day operations. Right? You had to run 24/7, millions of users, and some bursty sporadic traffic, and with a different requests, different use case. Everyone forgot about that until now. So they're only talking about the building the factory, but how to run the factory, we don't know yet, actually. We are still trying to resolve that issue. So basically, that is exactly what's happening now. Now the focus has been shifted towards the inference now, and talking about we have these big, beautiful machines like H100s or B100s, right? So powerful machines, literally. But we don't have a software to run them. We don't now have like an operating system to run them. That is exactly what is lacking right now. How to make the most out of these GPUs, how to squeeze every juice out of this GPU, right? But we are still using these open source models like VLLM and SGLang like frameworks. I mean, they're beautiful to execute the model, but we still need that runtime that sits on top of the GPU, that controls the GPU memory, and it does the model management, memory management in real time. That is exactly what is missing. We need that like a low-level runtime to execute these models efficiently. So it's fundamentally it's broken now, but that is exactly what InferX is here to solve that problem by sitting on top of the GPU and functioning like an operating system.
So you solved some problems with the cold start. What else is holding the market back? What other unsolved challenges do we have?
The cold start is a huge bottleneck, and also the reliability, of course. I mean, reliability in the systems, infrastructure, basically. You don't know when the hardware fails, right? Because that's exactly the reason the enterprise adoption has been really slow, is because of not only just the cost, but the reliability factor. They still don't believe that the infrastructure, the cloud infrastructure they're deploying it upon. So for example, we are working with this data center. They are building a 6,000 cluster GPU data center exclusively for inference, literally exclusively for inference to serve the enterprises. And they approached us and they wanted us to be the provider for them. So we're going to see more focus on inference focused on the data center wise as well. But the reliability factor is absolutely that they don't just trust the infrastructure right now, because it can break anytime, literally. It can collapse anytime in the real time, literally. So it's going to take some time. It's going to take some time for the enterprise adoption to grow. But for now, they're not ready yet. So the cost and the reliability factor. So both are the factors that's affecting this AI adoption into the enterprise. Yeah.
I think you mentioned something similar to that in some of our customer discovery conversation.
Yeah, no, we've seen a lot of that. We're talking to a company that does a bunch of batch processing of like large insurance documents, and they need a lot of large context windows, and they need these models to run for what. And part of the problem they have is like so many of them. I mean, they use all the providers plus some of their own hosted stuff. They use everything they can use. and a lot of it is because like these processes die and the hardware fails, and
Yeah.
and when it's what's really interesting, right? Which is your compute processes have historically been so small to execute a few instructions, and now that you're running these models where you're like these reasoning models and they're long and they're running
Yes.
for minutes and whatever, it's like your probability of something going wrong on a given run is much higher. And it's going to be weird to see how the market will adapt to it, right? These are technical challenges. We'll solve them.
Yeah.
Everything will get more stable. But it's.
Right now we're on a very elementary stage in running these models. Very elementary. Literally, we have a long way to go, right? So, but the infrastructure is not ready for that. Absolutely not. Yes, we are doing the batch. Yeah, batching is good. That can be very efficient when running the models.
But it doesn't work for like agentic though, right? If you're like expecting to ask an agent a question and get something back quick.
Yeah, batching is basically because you're combining these all requests and you're literally processing it together. So, but once it is done, then what happens to the GPU still sits idle. So that is exactly what's happening. Yes, all these agents clubbed together and thrown into the GPU VRAM and it's processing together. That's a good way to become efficient. But then there's a cold start problem as well at the same time. So it's a GPU idle problem, literally. Yeah. So we can't just keep the GPU idle 80% of the time. So that's a huge inefficiency.
We've got this, because you're talking about serverless. So the idea is to have some sort of containerization technology, is that right? So the idea is that you talk about like an operating system. Is this something that, like, if I'm deploying this, how do I think about this? Do I have to run a certain version of Linux? Do I have a certain hypervisor or some technology that handles the containerization, and that's where your sort of secret sauce comes in? Like, can you talk a little bit more about like where your solution fits into sort of the whole stack? If I'm a customer and I want to deploy this.
Yeah, absolutely. So the cold start is one problem for the serverless. Okay, this cold start is one problem, and then there's a problem for the isolation. So you have to serve these models in a very isolated manner. So when you can deploy 30, 40 models, but you have to make sure every model is isolated. Is it right? So that's the huge problem. So yes, there are some folks out there. They offer GPU sharing, actually, GPU slicing, but the isolation becomes the important factor. So what we built is we built our own runtime around it, literally. So what happens is that's where we kill the cold start and we manage the models in real time in a very isolated manner. For example, there is only 3 container runtimes in the world, literally. One is Kata, and one is Google's GeoVisor, and the third one is the InferX. So we have built this exclusively for the AI workloads to run these models in real time efficiently. And we are the first one to do so, basically. And to answer your question, I would say this abstracts away everything for the users, basically. This is like an operating system, basically. You just deploy it on a GPU and forget about it. That's it. It's like you take a OS for the computer, you deploy it, and you run all your applications on the computer, on a laptop, literally. It's as easy as that. So we provide the multi-tenant isolation. That is exactly what that means when the multi-tenant isolation. Every model, every request becomes a virtual machine itself. That's how deep the InferX goes with our own runtime. So yes, we did build a runtime around it. It's not just about the cold start, and we had to run them in a very isolated manner. Yeah, I hope that clarifies the question. Yeah.
Let's wrap up and talk a little more high level. There's a lot of talk about an investment bubble in generative AI. And you're in an interesting position that you get to see like what people are actually working on, right? Because you get to see what's being deployed, who's actually at the point of needing inference and not just kicking around little pilots and stuff like that. From your perspective, what areas of the market do you feel like are durable, they're real, they're going to be here? And is there anything that feels like hype?
There's a lot of hype, obviously. The valuations are really crazy right now. There's models, okay, there's one thing, okay. And the hype is mostly around these wrappers. That's what I call it. Everything, okay, you take the API and it's wrap some nice UI around it, and then you just sell it as a product. And they get funded very easily. They got funded even back in 2022, 2023. But they don't have any moat. that is exactly where you were locking. Okay, so what is sustainable is not the wrapper. So for example, there is an email agent. Literally back in 2022, as soon as OpenAI came out, there were like a bunch of wrappers as AI agents, and it's released into the market, and they got funded enormous amount of money, but they don't really have any moat behind them. And then the OpenAI itself comes out with their own email system, and that's it. These are all gone. So that's it, because everyone uses OpenAI. So what is your moat? No, we just a wrapper on OpenAI itself. Then the Perplexity comes out with their own email agent. Just like this last week. What I would see where sustainable investment should go is because of infrastructure that is built on top of the GPUs, how to manage these models, in a real time. Not even infrastructure, not just built on top of the existing software either, like a VLLM, SGLang, nothing like that. But there's going to be more. There should be more focus on the software layers on top of the GPUs. That is going to be the more sustainable factor, because we're going to see system breaking up in pieces pretty soon. But I would definitely focus on that. But there's a real hype, but also there is a fake hype as well at the same time. So yeah, what we are here to solve is what we call it a civilized inference. That is what we are calling it, actually.
Nice.
Yeah, because it's chaotic out there. It's really chaotic.
Yeah.
So with inference, that's exactly what we want to solve. Yeah.
You're abstracting some of that chaos, right? And
Absolutely.
You keep saying like 50 models. And for some listeners, the headlines are Anthropic, Google, right? OpenAI. But it sounds like we're entering a world where there are many, many different models that people are going to need to leverage. And you want to talk a bit about like why that's happening and
because when you're talking about multi-agent system, right? Agent is nothing but a model, basically. That's the model behind the agent.
Yeah.
So everybody is going to have their own model in the future. Mark Benioff of Salesforce, they're going to deploy billion models in the next 1 year, literally billions of models, literally. So every model, every agent is a model itself, basically in the background. That's what it is. So that's why in the future, there's going to be, if you look at the financial institution, right, there's going to be a fraud detection model, there's a customer care model, and if you look at the healthcare, there's an image processing model. So there's going to be multiple models for in every company. So with that, I would expect to see literally every person in the world is going to have their own personal model that will enable everything for them, basically. So it becomes their own assistant, and it does everything for them. So that is the kind of the future we are talking about. So it's like a billions of model. Even maybe person might have their different models for themselves as well, for their healthcare, for their healthcare, it's a different model. For their financials, different model. For the lifestyle, it's a different model. Yeah, who knows? That's the reason we are talking about multi-model, is because of that. So right now it's okay. We are talking about few hundred. If you look at the Hugging Face, actually, how many models are there? 2 million.
Wow.
2 million open source models, and it's growing exponentially.
Yeah.
Every year, literally. So, but how are you going to run all these models?
Yeah.
Okay, who is going to run all these models? You can just keep on dedicating a GPU and adding on a GPU to run these models, right? That is exactly where the infrastructure focus comes into place. So the system is not built for that, but that is exactly what we are trying to do here. Yeah, it's a very chaotic world out there. Literally, I know we don't really see that. We only see the very shiny parts of it, but underneath the hood, crazy chaos. Literally, yeah.
Well, Prashanth, thanks for joining us today. And for any listeners who want to learn more about InferX, we'll link to the site and the blog and some other stuff in the show notes. And I'm sure they'd appreciate it if you reached out.
Thanks so much. Again, I would love to come back, and maybe we should do we should do more focus on the inference as well, actually, because that is exactly what's going to decide the future of the AI world, where we're going to run these models, how we're going to execute. Yeah. But yeah, thanks for having me.
Thank you. And if you're building in the inference stack or thinking about AI systems orchestration, please reach out. Also, be sure to subscribe, like, and share. Thanks for tuning in to Inference Time Tactics.